Welcome. I'm Clive Natras. Welcome to this talk. It's a hydrogen talk. We've had one that's Hynet specific. Today you've got Sally, the master of hydrogen. She's going to tell you about it across the nation in a lot more detail. And we've got Alan on from Yenbach, who's going to explain that CHP isn't dead for us. We are recording this, so if you don't want to appear, will you just turn your camera off? And we'll go on the website shortly after the talk. And if you could keep yourself muted, if you wouldn't mind, you can put questions in the feed and we'll do our best to answer as we go along. Failing that, we'll post the questions and answers later on. I'll hand over to Mary. Mary, do you want to take it from here?
If you just toggle through to the next slide, I think you've covered what I would have said anyway. So yeah, so I think let's just run with the agenda.
Okay. So this is part of the program. There are several routes to net zero: geothermal energy, heat from earth, hydrogen from, which you'll hear about in a minute, green district energy rather than not green district energy, and then some other technologies which we'll cover next week. So this one's the second hydrogen talk. First one was about Hynet itself. This one's more nationally. Okay. So I'm going to first show you this map just to give you some background. The green bullseyes are sources of hydrogen on their way. Most of them aren't there now, but they're coming, sources of green hydrogen. You'll see them sprinkled around the country. So the northeast, Hull, Norwich, a little bit around London, not much. And the northwest, Hynet is there. And then the trust that we've identified as being within the reach of hydrogen in the shorter term, maybe in the longer term, everybody will get hydrogen, but in the shorter term are the blue dots. So there is potential. There is a lot of potential sites that could use this as part of their net zero plan. So I'll go on to Sally, who will talk you through the hydrogen piece. Sally.
Thanks very much, Clive. Just before I start, I just wondered if we could have a bit of audience participation, please. So we've got 44 people in the call. Could you please raise your hand if you've not heard from me before, if you've not seen me talk about hydrogen before? If you could just all raise your hands and we'll see how many hands raised we get.
Well, it's a much scurrying for mice there, Sally. So. All of them. There you are. Yes.
Keep going. Any more? Has anyone else not heard from me before? Because it's quite important, just so I know where to pitch it. So sounds like around half of the people haven't heard from me before, so that's really helpful. Thank you very much. Okay, so I am, and you can lower your hands again. I'm Sally Brewis. I'm head of regional development at Cadent for the Eastern region and North London. We also cover the Northwest and the West Midlands. I'm going to talk to you about hydrogen for Cadent and our regional programme. So could we go into the next slide, please? So we cover around 12 million supply points across the Northwest, all across the Midlands, the East of England and North London, 132,000 kilometres of pipeline. And our ambition as Cadent is to repurpose our networks to hydrogen. We think that that's the best option for green gas, and it can be made at scale in a low carbon way. So any hydrogen going into our repurposed network will be low carbon and will be subject to the government's low carbon hydrogen standard. And the approach that we're taking is to focus on industry and commercial organisations and public sector organisations first, while we await the decision from government on whether hydrogen will be used in our homes or not. So next slide, please. And the government is very supportive of establishing a hydrogen economy in the UK. They see massive potential for economic growth through this new industry, and they want us to be a leader in the hydrogen economy. Consistently over the past few years, there have been lots of different publication strategy documents, all of which state hydrogen as having a role, in particular for heavy industry, heavy transport, for flexible power generation, and also potentially for residential decarbonisation. The one thing that I want to highlight on this slide, well, there's two things. There's I've already mentioned the low carbon hydrogen standard, which will mean that any hydrogen that goes into the network will be low carbon, whether it's made from electrolysis or whether it's made from natural gas with carbon capture and storage. But the other really important thing on this slide is about the hydrogen production business model. Just in the same way as for the last 14 years, government have been subsidising offshore wind to get that technology off the ground, to bring prices in generation from offshore wind down. They've used a contract for difference mechanism for offshore wind, and that is the mechanism that they are proposing to subsidise hydrogen. Cost of hydrogen, producing hydrogen, is high now, but it will come down over time. And what government wants to do is make sure that the price the end user pays for low carbon hydrogen is as close to natural gas as possible. So that production business model is very important when you're thinking about how much the hydrogen might cost your organisation in the future, if that's the route you choose to decarbonise. Next slide, please. So we've carved up our regions, our full network area into regional hydrogen schemes. So you may have heard about the Northwest programme and the talk that was done recently on that by my colleagues. But we have a regional programme for all of our network areas. So we've got East Coast Hydrogen covering the East Midlands and South Yorkshire, the Hydrogen Valley covering the West Midlands, and that stretch over towards Bacton in the east of England, which would be a major hydrogen production centre. And then you've got Capital Hydrogen covering the east of England and London. SGN cover the lower part of that patch, so South London and then the southeast. So we've got a programme for each region, and they're all at different stages. Move on to the next slide, please. So we've discussed Hynet in the Northwest, which is our most advanced hydrogen programme. So that's approaching the DCO stage, where we get consent for this 125-kilometre pipeline, which is the initial stage of Hynet. Over in the East Midlands and South Yorkshire, the Humber will also be a major hydrogen production hub, and there's lots of heavy industry and commercial organisations that use lots of natural gas across this region. And where you can see the blue line that goes down to Thedlethorpe, and then from the Humber across to South Yorkshire, and then south from there via Nottingham, Derby, Leicester, that is a new transmission pipeline that Cadent are intending to build in order to serve local industrial, commercial and NHS organisations in those regions. The stage that we've reached with East Coast Hydrogen is that we're currently at pre-feed, and what we've done is, working with Clive and Mary, we've included the NHS sites in South Yorkshire and East Midlands in our pipeline routing and sizing study, so that if trusts choose hydrogen as the route that they want to go, your capacity is included within our plans already. But what we will need, and I'll come to talk about next steps later, is to engage more closely with you, any trust in that region, in order to look at your specific site requirements and understand, if you were transitioning to hydrogen, what your plans might be. So there is a next step, which is that we will need to start to engage with you if you think hydrogen is the option that you want to take and you're based in the East Midlands or South Yorkshire. Next slide, please. So it's just to show really through this slide that our programmes are very much supported by industry, by producers, and to give you some confidence that these are real, these programmes. We have a lineup of hydrogen producers, which were alluded to right at the beginning. We have loads of industrial customers who've submitted forecasts just in the same way as we've received for the NHS sites in this region. There is lots of support for these programmes, and that's very important because we need to demonstrate to government that these pipeline programmes are needed, and that is important so that we can get funded for the next stage. So East Coast Hydrogen, we're at the pre-feed now, the pre-front-end engineering design. In early next year, we will submit what's called a reopener to Ofgem to request funding to move into that feed stage, and having support from organisations in this way is very important to demonstrate that need is there. So that's another reason why we need to start to talk to trusts in this region, if you think hydrogen is the option that you may take, or if you want to explore further. Next slide, please. Thank you. So this slide is zooming in on part of the Capital Hydrogen region, which covers the east of England, London, and the southeast. Within this region, there is industry, but it's quite dispersed. which makes it more difficult to justify huge transmission pipelines in advance of that decision in 2026 on whether hydrogen will be used in our homes. So in this region in particular, we're focusing on hotspots for now until that decision in 2026, when everything might change. If government says hydrogen will be used in our homes, we'll be looking at how we can get hydrogen out from the production centre at Bacton in East Anglia to those towns across the east of England and then into London itself. So big change, big decision in 2026. For now, we're focusing on hotspots where we know there's lots of industrial demand, which is close to hydrogen production. East London and Thurrock is one of these such examples. There are others, and it wasn't highlighted on the map, but I wanted to flag that we're also starting to become aware of a really strong opportunity in the Kings Lynn region, which is, I believe there's a hospital there. And so my message really from this slide is, the West Midlands and the east of England and North London, it is further behind East Coast Hydrogen in the Hynet region, but we have schemes coming forward in hotspot regions. So if you think hydrogen could be important for your decarbonisation plan, please do reach out and we'll see how we can link it into one of our growing hotspots, or it might be enough to justify a hotspot in itself. So just because your scheme isn't in our furthermost regions doesn't mean there couldn't be a hydrogen option for you. There are other organisations also, organisations like Carlton Power, who are looking to generate hydrogen close to sites, so build site-specific hydrogen generation, basically. So that could also be an option. If you're not within one of the regions that has access to a major pipeline, potentially you could look at either on-site generation or close by generation of hydrogen through a company like Carlton Power, and there are lots of others, RES, in order to meet your potential hydrogen needs. So there's lots of options on the table from a hydrogen perspective. Next slide, please. So that brings me on to the next steps. If you are in the East Coast Hydrogen region, so this is East Midlands and South Yorkshire, and you're interested to explore, what that connection could look like in the East Midlands for your hospital site, then please do reach out through Mary and Clive. Be really pleased to talk to you. And in other regions, such as in the West Midlands, East of England and North London, please do reach out in a similar way if you think that hydrogen could be important for your decarbonisation story, because we can look at what schemes we have, what hotspots we have close by, and whether to connect you to the range of producers that we're in contact with that could potentially create hydrogen, close to your doorstep. The other thing just to mention is that for East Coast Hydrogen, we have some major communication points coming up very soon. So we've got a particular focus on the East Midlands area at the moment, so Nottinghamshire, Derbyshire, northern part of Leicestershire. We've got a big event coming up on the 22nd of September at Toyota, and any local trusts would be very welcome to join us. We're talking about localised, basically the really strong story that there is in the Nottinghamshire, Derbyshire and northern Leicestershire area. There's huge production potential. We're hoping for a big announcement from Uniper, and we can show just how strong the support is. We're inviting DESNZ, inviting Ofgem, demonstrating the real opportunity in that region. And then for the wider East Coast Hydrogen region, we are moving towards a delivery plan. So this is a cross-network plan which covers the northeast as well and the East Midlands, and that's on the 13th of November. So if you're interested in getting involved in those, please let me know. Am I out of time, Clive? Is there any time for questions?
No, there's time for questions. We've got to, Sally, for only a few more minutes. So
Okay.
This is a very good time to speak to her if you want to ask her some questions.
Yeah, please.
We took the sharing off so that we could see
Perfect.
each other a little bit.
Thank you. So does anyone have any questions on any of the regions that I've covered?
Mary, have you been watching the flow? Perhaps we can pick anything up from the flow that's going on.
Yeah, no, the main question in the flow I've answered, and it's really around the relevance of this meeting to a particular trust. As you know, this is clearly just for the East Coast Hydrogen opportunity. So yeah, nothing else. Yeah, just by show of hands, presumably if anyone has a question for Sally whilst she's here.
The other thing I should say though, Mary, is although I did major on East Coast Hydrogen We also have regional programmes covering the West Midlands, the East of England and North London. We also can connect trusts to other gas networks. So all other gas networks are doing the same things as Cadent. So if you're in the Northeast, it's very easy for me to connect you into NGN, who are doing exactly the same as Cadent for the Northeast. Similarly, for the Southeast and South London, we can connect you to SGN. So, and obviously we have contacts with Wales and West Utilities as well. So we can help to facilitate other conversations. So just
I think what would be useful to note as well, because what we do have is, because we still have a number of trusts that haven't necessarily been mapped to those existing opportunities. You talked about on-site generation and some of what's coming in the pipeline. I think it'll be useful for us to just do some mapping around that so that site trusts have a clearer view of, and because this is really around addressing those technologies that may be relevant for decarbonization, and then obviously the pipeline and the program comes on the back of that if it's technically feasible, and then obviously commercially viable for them as well. There is a question for you. There's a comment on the usefulness of this content. So, and there is a question on time frame for East Midlands and pipe supply. Do you have any? Can you respond to that, please?
Yes, exactly. So in terms of timelines, the first phase of construction, we believe, will start 2028 to 2031. The specifics of of how East Coast Hydrogen is phased are being determined, and the exact phasing are being determined through the pre-feed. The pre-feed is set to finish at the end of December, basically. So the technical work will be done by mid-October. So I will have more information on timings after the pre-feed is done. I'm very aware of the 2032 deadline that the NHS have, and I can totally understand the question. But if I'm happy to pick up offline with any.
I'll pick up timing later in the talk as well. So we can do that.
There is another question on and I think this is around the pipeline routing. So it's around how far would you deviate from the pipeline route to get to an NHS site? So what's the in terms of the viability of distance? So what's the distance? It's not what's going beyond, so to speak. Yeah,
exactly. What I should say is the route that you can see on the screen was done in the feasibility study, and it looks quite different to it now. It's just that we haven't got it published. So if you're trying to work it out by looking at the map, is this relevant for me? It's probably better just to have a direct conversation. I don't know the maximum spur length that we'll go to. It probably depends on the size of the customer and whether that sort of cost per carbon ton abated calculation that we'll need to do. So I'm afraid I can't give and even the pre-feed team won't be able to tell you that yet. But we've pushed through the NHS sites in the first wave of. So we originally had 160 sites in the East Midlands, South Yorkshire. All of the NHS sites have been pulled through to the final 54 that are currently being assessed. So hopefully that's some comfort. We do know that it will be difficult to get to a lot of the NHS sites because they're in city centres, but we're accounting for that through a separate project, the East Coast Hydrogen Distribution Project. So we're looking to see if we can repurpose existing distribution pipelines in order to connect to the transmission pipeline. And that how long is a piece of string? Like it could be possible to go longer distances if you're repurposing pipes instead of building new. So I would just encourage trusts who are interested in the East Midlands region to get in touch through you and Clive, and we can pick up directly to look at on a case by case basis.
Okay, but we've included the map shows the hospitals that we think have a reasonable chance of getting hydrogen within the 2032 window, but it's not going to be available instantly. There's a whole program which I'll touch upon in a while to get us all to the right place in time. Okay, Sally's going to go in a minute or two. If you've got any remaining questions for her, will you stick them on the web and she'll answer them for as long as she's around, and then I'll send them to her and she can add answers afterwards. We will put the answers up on the website, though we are taking a little while to do that. We're not the fastest, but it will certainly be out before we repeat this talk in a month's time. Mary's going to disappear as well at 1 o'clock, leaving Alan. Alan will be a mid-speech. We'll go through the his slides, and then I'll talk about the program in a bit more detail. So I'm going to put the slides back up, if that's okay. And and we'll take it from there. Right. Okay. So, Alan, let's have your bombshell about CHP.
Right, good afternoon. I'm Alan Beach. I'm a director for Clark Energy. We're the Jenbacher distributor for UK and 28 other countries, and we do project delivery on that, batteries, electrolyzers most recently. But if we could go on to the next slide, please. I'm going to switch my camera off, if you don't mind, till the end. I'll come back on later. Right, here we see the generation stack currently in the UK. That's the type of generation that's producing all our electricity. And you can see even on the cleanest day, we're still burning a lot of gas and even coal on that day. But gas, whilst it's efficient at the point of generation, it doesn't recover heat. And the benefit of that improved efficiency is generally lost by the time it gets to the point of use. So my point is, even during the transitional stage of a hydrogen economy, for the next 5 to 10 years, your CHP is actually saving CO2 at, compared to centrally gas power stations producing that energy. Be going to the next slide, please. Right. Anyway, the point of today is, will it become a stranded asset when hydrogen becomes readily available? You'll be pleased to know, and as a business, we're pleased to say that no, it won't be. We've been running on hydrogen for 20 plus years, up to 60%. It's a processed gas that flare stacks we run on. So we're quite familiar with it. And we know that all product lines that we've been offering are okay up to 20. We've tested up to 25% mixed hydrogen within the pipeline. And we also have a product portfolio that is available today to order that can run on 100% hydrogen. And that will be extended to other product lines as we go along. Next slide, please, Clive. Right, this generally what we're seeing is that where gas is injected at transmission and distribution level, we see it hydrogen from electrolyzer plants, green hydrogen, blue hydrogen where it has carbon capture, but we're also been seeing for a number of years and increasingly today, renewable biomethane being injected into the mains gas. And more commonly, that's having carbon capture at source. So depending on the feedstock, that too is carbon negative rather than carbon neutral. Next slide, please, Clive. So here's some of the techie stuff. As we bring hydrogen into the mix, it actually affects the wobble index, the methane number, and the heating value of the gas going in there. So these slides will be circulated later, but this is showing that really you're going to have to put more gas into the cylinder to produce the same amount of power. If you next slide, please. This slide here shows the benefit of CO2 reduction versus the amount of gas that's going in there, or hydrogen gas. So this shows that for 20% hydrogen mixed into with mains gas, you're actually only getting a 7% reduction in carbon. That's because the molecule of hydrogen is 3 times smaller and has 3 times less heating value of that of CH4. So it's a little gain on that initial stage. Next slide, please, Clive. Right, now, this is to show where technically we're ready for each phase of the transition of the hydrogen economy. So currently we have anything up to 5% hydrogen in a gas line. The engine will deal with it, coming down the same pipe as we have at the moment. Up to 25%, again, it's the same product with the same gas line going into the engine. It's the same. But as you start going above 20%, that brings certain technical difficulties in there, which other slides will show you in a minute. And then finally, we have the 100% hydrogen engine, which again, some of the next slides will show you the differences between type A and type C, type B being a hybrid of the two. Next slide, please, Clive. Now, this is showing where we currently are with our product line. The type 4, which is most prevalent in hospitals. In fact, I know there'll be a few on the call that will have type 4 engines that have in their current fleet, sort of Barnsley, Nottingham, and a few others that I managed to identify from a list of people who may have been on the call today. Now, Currently, as I say, Type 4 is available for 100% hydrogen release today. The Type 6 we're planning to have towards the end of next year for 2025 release, and so on for the smaller engines as well. So again, if you want to look at this slide, that shows you where we are from a power output as to where we will be on the various grades of gas release. Next slide, please, Clive. Again, a bit of a techie one here. This shows you that once we go above 5%, because of the flame speed of hydrogen, it starts to produce certain problems within the combustion process. So we have a risk of knocking within the engine, which can put undue stress on the engine. And we can also throw NOx limits out of kilter. So it's something we have to deal with. If you go to the next slide, please, Clive. So by monitoring the amount of hydrogen that's being mixed with the mains gas, we can control both the knocking, i.e. the peak pressure, and the NOx emissions back to current levels that are expected. And in fact, we can reduce the NOx levels below current engine capability. Next slide, please, Clive. This sort of physically shows you the difference between a Type A and a Type B and C. The one on the left is an engine that can take gas up to 20–25% hydrogen mixed. You see there's very little difference to an engine that you have today. All we need to do is to monitor what percentage of hydrogen is coming in that gas line, and we can adjust the engine, and there's no derate on that engine whatsoever. You know, an engine that's producing 1 megawatt or 1.5 megawatts today will pretty much run at that same electrical output. But you will need to put more gas in there, as I've explained before, because of that molecule size of hydrogen. Now, as we see, you see the yellow pipe on the right-hand side there. This is where we've gone beyond 20% or 100% engine percent hydrogen. We now need to start bringing that gas in at higher pressures. And we're talking about 8 to 10 bar now versus 150 to 250 millibar on the left-hand side engine. Next slide, please, Clive. So the main difference between the two engines is currently the gas and air is mixed before it goes to the turbocharger. Whereas with a hydrogen engine, once you've gone above the 25%, they don't meet until you're actually within the cylinder itself. So we're actually we're combusting the two and mixing the two within the cylinder. Next slide, please, Clive. Now this gets across a little bit of the derate. This is the Type 4 that we've released currently for 100% hydrogen. Looking on the right-hand side there, the 20-cylinder version is available on 100% hydrogen at just over 1 megawatt. Now, if that's on full methane today or mains gas, that would be a 1.5 megawatt engine. So we're currently seeing a 30% type derate by running on 100% hydrogen. But the good news is, as we see more and more hydrogen becoming commercially available, because it's not there today, the R&D side, we know that we can, by getting towards 2030, get back to the same output that we're seeing today on natural gas. So that 20-cylinder, we expect to be back up to 1.5 megawatts. And we also know, because we'll be delivering at much higher pressures, the hydrogen, that we can get that mix in there, that we will be exceeding 1.5 megawatt beyond 2030 with 100% hydrogen. Next slide, please, Clive. Here's a business case of, say, we've been running on hydrogen for 20 plus years, but this is a project that will be commissioned this year. And this is where we're putting 6 1 megawatt hydrogen engines into a data center in the Netherlands. That will have 30 to 1 hour storage on site to run all 6 engines on 100% hydrogen. Now, they calculate that 90% of their events don't go beyond that 30 minutes. So that will mean that they are 100% clean for any mains outage they have. But the engines are set up that if that event goes beyond the hydrogen storage on site, that it will smoothly and transit over to mains gas without a glitch. So, you know, whether you go in 100% hydrogen with mains gas as backup, the technology is there to handle that. Next slide, please, Clive. Right, and also CHP, we're not stopping at pure decarbonisation of the gas. We're looking at more and more CHP working with heat pumps, supplying heat pumps from the electricity, but also what we've lost heat from the second stage intercooler system. Previously, that's gone straight into a cooler. We're now feeding that into heat pumps, so improving the coefficient of performance of a CHP from, say, 90% or 0.9 to 1.2 to 2 times the coefficient of performance of a traditional CHP. We've also got carbon capture within the exhaust gas systems. We've used that in greenhouses for many years, food and drinks industries for putting the bubbles in fizzy drinks, etc., or the holes into crumpets. But we're also using it now to create commercial products, byproducts, precipitated calcium carbonate, which is used in paper manufacture. So that carbon can be used for additional revenue. And also CHP in a decentralized with AI attached to it, it can run with localized wind, solar, diesel generators, presumably running on HVO, sort of carbon reduced fuels, etc. This sort of microgrid can run, so it's looking at what is the greenest, which is typically the cheapest means of electricity and heat production on site. So there's a long life for CHP until the hydrogen becomes available in many guises. So the answer is CHP will not be a stranded asset, and your existing fleet can be modified to run on hydrogen. Clive, I think that was my last slide.
Brilliant, thank you very much.
Okay.
So there have been a lot of questions about when this is going to happen and what's going to happen. So a few points I'd like to make in this regard. Hydrogen is going to be available over a lot of the country, but over a staggered period of time. So we've concentrated on the hospitals that can get to net zero, the big emitters, and get to net zero by 2032, and we've showed you those on the map that we did earlier on in the scheme. If your invitation to here said for your diary, then you were seen as a representative of one of those sites that can take hydrogen within that time period. If you got an invitation that just invited you to the talk, then we haven't seen your site as being one that can take hydrogen. So there's a clue as to how we've categorized you in your invitation, as there is for the geothermal and other routes to hydrogen. Now, a lot of things have got to go on to get hydrogen ready for you, and you heard that they're busy with pipes and all the rest of it, and that's great. But we can't just sit down and wait till hydrogen's there and then work, because we have to get our sites ready. Now, the nice thing about hydrogen is that you can have steam, you can keep steam. It's the only net zero technology where you can viably keep steam at the moment. So if you've got steam and you've got a very good system and you don't want to go to low temperature, which is suitable for all the other technologies, then hydrogen better be one that you back. If you do need to de-steam, well, that gives you the choice of the different technologies. So the question that we're trying to get together is, how do we coordinate the different producers of hydrogen, because they're coming on at different periods of time, the hospitals, your particular needs, and what each of you has to do before you can get there, and get that all together into a sensible program form. So the things that affect your sites that we don't know is, what's your site condition, what's the backlog, do you have a problem with funding to get that sorted? What are your opportunities, whether you can hydrogen and geothermal or whatever? Some people can get both. And then something called the site ecosystem, because most of the big emitters have an NHS ecosystem around them. And of course, if we can get hydrogen to the main site, then there's a good chance that we'll be able to get it to the nearby users as well, and green them up at the same time as green the hospital. So if you've got a steam site and it's in bad condition, then you probably ought to consider de-steaming, and that's going to take a few years to do and needs to be integrated into the whole program. We need to deal with the capital cost and how it's going to do that. If you've got CHP and you're enjoying the benefits of CHP and you'd like to keep those, and you're going to get hydrogen, that's the only way really to keep CHP. So hydrogen will work for you because you can blast away, suck as much hydrogen you like, and carry on generating power. So CHP is a good friend to hydrogen because you'll be getting subsidized hydrogen and you'll be using it to generate heat and electricity. So with geothermal district heating technologies may pay for themselves, and we'll deal with those in those sessions. But hydrogen is a miracle bullet in a way. Now, some of you asked about the what about electrolysis? Well, there are a few things about electrolysis hydrogen. Firstly, it's much more disaggregated. So getting the suppliers like Carlton to talk to you, we've already talked to them, is part of what we'll do with the workshops at IHIM. So if you want to deal with one of the other suppliers, I will have several of the suppliers there. You can meet them face to face and talk to them, and see whether you perhaps want to work with them. Now, it's no point using electrolysis to drive CHP, because otherwise we've turned electricity into hydrogen, and hydrogen back into electricity. That's not a very good thing to do. But we have mapped all the NHS sites that have excess land of a certain size and could take a hydrolyzer on them. And we have that list of hospitals. And if you're one of those and you've got an electrical ability to get an electrical connection onto that site, then that's definitely an option for you. But you may need megawatts of electricity to produce megawatts of hydrogen energy. So you imagine the efficiency is not 100%. For an electrolyzer, it's about 60%. The technologies we'll show you next week are more efficient than that, but they don't use electricity. But so you need a decent period of site area, and you need either a source of solar energy, which we'll cover next week, or you need another form of electricity, or you need a good solid grid connection, and that's hard to get in the NHS unless you're lucky enough to have one as well. And these are all parts of the streaming workshop exercise we're going to do at IHIM, and that's where we're going to need you there. So the support you're getting from the NH Power collaboration, which is all the people you've seen invite you today, is we put together these talks in August and September. So this talk is recorded, be on the website, and will be repeated in September. We'll learn from this, so it might get a little more content, who knows. At IHIM, we'll have workshops, we'll have as many of the contractors and suppliers as we can get there ready to talk to you. If you come armed to the workshop with your site needs and your site condition, then hopefully you will leave that by having attended a workshop and having an idea about what kind of a mountain you need to climb in terms of timing and the rest of it. And then in November/December, we'll have the roadshow, and we'll attempt to cost schemes for you. So you can walk away and say, right, I'm going hydrogen. What kind of investment am I going to talk about, and what kind of savings or revenue cost am I going to have coming out of that? So for your net zero plan, which you meant to have ready for March, if you come as far with us to the workshops, you should be zooming in on the right net zero route. And if you attend the road show, you should get some costings to allow you to put them in your plan as well. And then the idea is that NH Power will continue to support you as best we can through the implementation phase that goes on. You've seen all these are all the dates for the various talks. So you've got those, you've got them in your invites. I don't need to do them now. You've got the workshops. The initial invites for the workshops at IHIM have come out. I haven't put the individual invites to the individual sessions up yet. But if you, for instance, if you are a hydrogen site and we think you can get hydrogen, then your invitation will urge you to attend rather than just invite you to attend. So by the end of that, you should have your net zero route and be ready for the road shows. And then the road shows, we really want you to be writing effectively part of your business case for your net zero plan and having as much support from that as we can give you. Now we've got a couple of minutes left. I assume we've been having questions. Alan, have you been receiving any questions on the chat?
No, I seem to have got away with it, I think.
You've got away with it, so we either sent everybody to sleep, or you answered every question they can think of, or who knows what. So I'll stop sharing. We've got a couple of minutes left. If anybody wants to ask a question, you can either put your hand up and ask it, or we'll put it in the questions and we'll either type your answer or do the rest of it. So that's where we are on that. The video will go up later today. The questions will go up as soon as I can do that in a couple of days' time. We've lost Mary, unfortunately. She'll be at the next session if you want to grab her. She'll be at IHEM if you want to grab her. We've lost Sally because she's out there lobbying for the hydrogen for us as we speak. She's on the call for it. Sally will be at IHEM too, so you can meet her face to face along with some of her Cadent colleagues. Okay, I can see there's a hand up. Ehsan, do you want to state your question?
Yeah, thank you, Clive. Question to Alan. I'll put it in chat as well. Alan, what do you think the cost of the hydrogen in comparison to gas? When you do the calculation for if the CHP is viable to operate or not, you basically the gas cost is one of the main factors.
Well, let me come in there first. So the idea is that the gas that comes through the pipeline will be subsidized. So what's going to happen is that gas prices naturally will get a levy put on them that lifts the price of gas and drops the price of hydrogen. So you should be paying the same for a kilowatt of hydrogen as a kilowatt of gas. So this is a really good opportunity to green up at no cost, so to speak. And that's the whole thing of the hydrogen business model, it's called. The hydrogen business model does not yet apply to all the electrolyzers and all to the other decarbonizers that I'll show you next week. But if you can get piped hydrogen, I would really try and go for it because it's going to be subsidized, and that, you know, very few things are subsidized. Do you have any other questions?
Could I add to that, please, Clive? That how it will develop is like a microgrid, and the CHP will not run as long as it runs today. It's more likely to reduce down to say 4,000 hours because it'll all be running against the price of electricity, etc. So it depends on cost of electricity. So your CHP will have thermal stores, etc. But when electricity price goes up, then you switch your CHP on again, because when electricity price goes up, that really means that there's not enough solar on the system and the wind isn't blowing as hard as it needs to be. So it's going to be a direct correlation to the central systems back running on gas. And as one of my first slides said, that it's great that you can run gas with hydrogen mixed into it, into a centralized power station, but they're not recovering heat. And so their 50% plus efficiencies, electrical efficiencies, are lost by the time it reaches your point of use. So that's when you fire up your CHP. And if you're only running, say, 4,000 or 6,000 hours a year, then that just means that the life expectancy of your CHP has gone up as much. So 4,000 hours a year is half of that of 8,000 hours. So a 15-year lifespan of a CHP is going to last you for 30 years. But the actual savings, because high electricity costs, are going to be even more dramatic, because when the wind isn't blowing, electricity is going to be very expensive.
And that's all a question about maintenance. Maintenance contracts are priced in various ways, but you can pay for maintenance per kilowatt hour or per hour run. So if you want to run for less years, you should pay less in maintenance.
Yeah, Clive, maintenance is based on hours run on an engine, so it won't directly half, but it will be close. So,
okay, guys, we're just about at time. I know I booked you to 20 past, but that was to give us a little leeway. Unless anybody raises a question in these last few words, I will thank you for coming. It will be repeated. We're working very hard with the hydrogen providers and happy to be a conduit or support to you as you try and talk to them, because I don't think Sally really wants 209 email addresses to service to all the high emitter sites. So we're trying to gather things together and help with that. And the NH Power collaboration team are trying to manage that process as best we can and act as your interface. So thank you very much for attending. Thank you, Alan, for your talk. The video will go up shortly, maybe later today or maybe tomorrow, and then it will be repeated on a Wednesday. I made the next session on Wednesdays in case some people work part-time next month. So thank you all for attending.